CloudDB, shaping your new normal.
Hello everyone, welcome to the Oracle Groundbreaker session on innovation with converged database and autonomous database. I'm Gautam Pisharam, a domain specialist from Oracle EMEA Analytics team, and let's explore together on how knowledge graph of citizens can enable an organization to detect tax fraud. Before getting into the demo, let's take a quick look at where graph analytics as a solution fit in relation to an Oracle converged database or autonomous database. Like any organization, the very first step will be to collect and organize the data from the multiple data sources and organize it in a relational database like an autonomous database. And that includes collecting information into various tables, getting them in an organized way into multiple columns, and making sure we have the primary keys and the foreign keys as the joins in establishing the connection between the various tables that we have collected from the raw data. And once we make sure the relational database is all set, we then try to create a graph model out of it. When we say graph model, it is the process of generating vertex tables and edge tables, which led the organization to derive relationship based on the data that resides in the autonomous database. And once you have the graph model built in, we have the built-in capability to load that massive volume data into the in-memory so that we can either execute algorithms or we can query the patterns or insights on these patterns from the data that resides in the in-memory. So if you look at the visual representation beside step 4 PGX in memory, that's how a graph is visualized based on the vertex tables and edge tables. And once we have the information in the vertex table and edge table, and once we make sure it is loaded to the in memory, we have the component which we call as GraphViz, which is part of Graph Studio to let an organization visualize the various patterns from the raw data. We will also take a look at what exactly is a graph. And in this example, we are trying to highlight the importance of a graph using a very simple example by the name financial transactions. And like the name, the graph involves transaction of various amounts between different account numbers. Any graph will have a unique name associated with it. And in this case, the graph name is financial transactions. And the thumb rule of any graph is that it will have a vertex and an edge. A vertex is also considered as a node, and an edge will be the relation between different nodes. So in this example, we can see that there is a transaction of nearly $10,000 happening between the account number 2090 and account number 10039. So the main vertex of this graph is an account. And then we have the concept of edge, which could either be the owner of that particular account, and then its associated properties like what was the event that happened between two different accounts. In our case, it will be a transaction, and the actual amount of transaction that involved between two account numbers. The account number will have an account owner with its name. So obviously, like we have vertex and edge, we will have labels and properties associated with the vertices as well as edges. So the label of vertex can be the person, or the name associated with the person associated with that particular account number. And similarly, we will have label of edge as well. In our case, since it deals with transaction between different account numbers, transaction will become a label of the edge. Similarly, we have property of vertex, which is the account number. So account is the vertex. The person associated with that particular account will become the label of the vertex, and the account number will become the property of the vertex. And similarly, we have an edge, which is owner of, and the label of an edge can be the transaction. And similarly, the property of the edge can be the actual amount that was transferred between or different people. We can also have different properties associated with the vertices. So say for example, the transaction was happening between account 2090 and 10039, and we can see that the person who is owning the account 10039 works for a different company. And there are also transactions involved between that particular person and the person Camille from a different perspective as well. So we have Nikita as a common contact between the two accounts that links them in the transaction, and finally that transaction comes back to the person who initiated the transaction. This can help an organization to visualize the pattern in which the people were transferring the money, and can find out if such a transaction was genuine or if it is fraudulent in nature. So rather than just focusing on the numerical data like in a traditional analytics, graph analytics more try to focus on the pattern in which the events occurred within that particular data set. Now that we have had a brief look at how a graph will look like, let's now try to understand what can graphs do. What happens when you try to derive a graph model? What are the sort of insights that you can derive from graphs? So this particular slide will be to focus on some of the common patterns that we try to identify as part of graph analytics. And these patterns holds true for any graph, be it an Oracle graph or be it a different graph offering from a different product. Some of these patterns will be highly generic in nature, and that includes the first pattern that we are going to explain here by the name cycles. The second pattern will be ranking, and the third pattern will be path analysis. And then we also have clustering or partitioning through communities. So these are some of the patterns which will enable the organization to detect insights on the various events that are happening within the organization. So to start with the cycles, on the extreme left of this particular slide, we can see that there are red nodes and yellow nodes. And we can also see that the yellow nodes are central in nature, wherein there is a transaction initiated from the yellow node to a red node, and that transaction comes back to the yellow node as well. Now, if you try to translate this information to the financial transaction example that we were looking at earlier, what we can assess from this, there is a transaction happening from the yellow node to the red node and comes back. Similarly, there is a transaction that is happening between the yellow node and a different red node and comes back. There is also a transaction that happens between various other red nodes as well, and that insight stands true for the other nodes as well. Now, there are two areas in which a cycle can help an organization with. One is in the positive side of it, and one is in the negative side of it. So the positive side is that let's take the example of a financial bank. Now, a financial bank, they try to identify the pattern in which their customers are making the financial transactions, and if they find that there is always a set of friends that tries to leverage the banking services, or if a set of friends are trying to use an online retail portal to do shopping, they can identify those patterns and then offer recommendations based on what they're trying to buy. If there are similarities between different groups, then they can group together as a community, and then they can offer recommendations to multiple groups involving multiple people, and they get benefit from choosing the right way to shop using the machine learning algorithms in the background. Another way of looking at it is, let's say, for example, um, if the various individuals are transferring money between themselves, and if they are continuing to transfer the money between themselves or trying to leverage the banking financial services for a period of, let's say, 6 months or 7 months, usually banks, what they do, they can also turn on certain benefits, like trying to apply for a big loan in a matter of 10 seconds or 15 seconds, and try to release the money just in a matter of few seconds for the people who are trying to leverage the financial services for a long time. So it is also good for a customer, because they get added advantage that they can apply for a loan, and they can get the loan in under 10 seconds or in under 15 seconds or as soon as possible, which works well for both the customer as well as the bank, because they are trying to repay the money as well. The customers are loyal to the bank and they get the trust, or and based on their scoring, they get more benefits. So life evolves good for both the customer as well as for the bank. But what happens when they are trying to use it from a negative perspective? So say, for example, there is a set of individuals with fraudulent mindset, and then they decide to simulate the same event, wherein, let's say, for example, there are five people involved. They try to transfer the money between themselves in different patterns for around 6 or 7 months, and then they get eligible to apply for a loan and try to leverage it. And once they get the loan in under 15 seconds or in a very quick manner, uh, they just vanish. They don't want to repay the money, which will be a big loss for the financial organization. So graph analytics will help an organization to identify and understand these patterns much before they try to vanish and try to red list such patterns, so that they can take measures for the future on how to avoid these kind of patterns from happening. So they can make sure they have security algorithms to red list some of these patterns which look suspicious in nature, where they are trying to leverage the banking services in a fraudulent way. Now, when it comes to um, the tax fraud or tax evasion, especially in let's take the example of India as a country. We have a very specific tax by the name goods and service tax across the country. It's like a unified tax service across the country, and people try to perform what we call as cyclic trading. So in order to evade from tax, what they do, they will have like multiple owners. They could be like fake owners. So they will try to sell goods from person A or company A to company B. They will try to sell the good from company B to company C. Then they will try to sell the good from company C to company D. Then they will try to sell the service from the goods from company D to E. And from company E, it comes back to company A. So they try to showcase it in such a way that a lot of manufacturing has been happening, a lot of movement was happening between different companies. They will have fake invoices, and they will try to generate fake invoices and try to show more tax, and then ultimately try to evade it as well. It holds true for one more case in relation to the value added services that we have in a country like India. So people try to perform cyclic trading to mislead the government agencies to make sure they pay less tax or they try to evade the tax. And these patterns can be um, well unearthed using a technology like the graph analytics to understand the fake owners or the fake middlemen. So the second pattern that we are going to introduce is called as ranking, and like it says, it shows the money flow to a particular individual from different sources, and that particular amount gets consolidated and then go to a very particular individual. It could be a firm as well, wherein a firm trying to attract a lot of money and then getting it to a different entity altogether. So ranking helps us to identify influencers. Let's say, for example, if there is a person who is trying to act as a middleman in case of tax fraud, and he's trying to collect the money and then try to make sure he um, try to offload it in multiple channels. It helps the organization to identify the influencers who are acting as a middleman between different groups, trying to organize the money and then do something about it. So these patterns can well be unearthed. The next pattern is path analysis. So what happens if you want to find a path which is suspicious in nature or a path which is interesting in nature from a multi-million data set? The data set could be like of massive volume, and what if we want to pick these interesting paths in real time and then be able to either offer recommendations or try to find out if it's suspicious in nature, so that we can red list those individuals and then send for further investigation. Path analysis will be much helpful there. The next set of algorithms are the community algorithms, like we see on the picture on the bottom right. Community detection algorithms help you explore groups of people or groups of citizens in clusters or partitions, and then help you identify who is acting as an influential member between different groups and who can connect you to a different group who is suspicious in nature, who is or who is doing some non-fraudulent transactions as well. And then obviously on the bottom left, you also have a very similar picture like the communities, which helps you identify who can get you close to a different group the most shortest and the fastest way. So, like we have in this screen, graph analytics not just focus on the numerical data, but it more focuses on the patterns in which various events occur within an organization, and let you focus on those patterns and make sure you can also look into the future and set the regulations to see that less of fraudulent transactions are happening or less of tax evasion is happening, which is also very vital and pivotal for a public service like an organization, to make sure the tax money is flowing in the most accurate and good way. So now that we have seen what a graph is and how a graph looks like, we also looked at what are the different patterns that graph can help with. Let's take a close look at what Oracle can do within a graph to be able to generate these patterns as well as insights. So one way to get these patterns is by using a feature we call as property graph query language. It's a language that has a lot of similarity with the structured query language from Oracle or the Oracle SQL. It's a language which can help you identify the pattern and then visualize the patterns on the screen. So in this example, let's say if the owner of a particular account is sharing personal information with other accounts, we can write a query, and that query will have a very specific pattern that we are interested in. So whatever pattern we are interested in, we can include that pattern in a query, and it will return the graph in a visually appealing way. So the first feature in Oracle Graph is to use the property graph query language, and the second feature is to use the built-in function And the third feature is to use the built-in algorithms. So there are many algorithms that we have, you can write centrality related algorithms, you can write community detection algorithms. So like it try to highlight between feature 2 and feature 3. You'll be able to call built-in functions to visualize the information in a meaningful group way, or you can execute algorithms on top of it and then try to find a very specific input. So you can find out whether a particular individual with a lot of page rank or with a lot of weight has been acting transactions which are fraudulent in nature. So you'll be able to generate these patterns or insights on these patterns based on a query language as well as by executing built-in functions and algorithms. In today's example, we'll be very focused on how an organization can leverage Graph Studio and visualize these patterns on Graph Studio by collecting the details on citizens in an autonomous database and generating a knowledge graph on top of it. So there are two methods I'm going to introduce. The first method is going to be a rule-based detection, and the second method is going to be a machine learning-based detection. So we're just focusing on the examples. We probably would not look in detail into the actual codes because we want to make sure this session is a visual translation of what is possible within Graph Studio for a team like a risk analytics team or an investigative agency. What is visually available to enable them to deep dive into the raw data that resides in the in memory, and how can it be helpful to find these insights. So if you look at tax evasion example and the very first example, which is rule-based detection, we have a person here. This can be the node or the vertex of the graph, and we can see there are many properties associated. So a person will be generating an income close to 1 million. He could be investing in a car of 1000 cc. He could be investing in a property of 300 yards, and yeah, it has information on the overall spend or the overall balance that he has in an account, all the individual information on a personal that can be collected by the government, and it will also have information on how much tax he has been paying. So in this particular example, the government is trying to keep the information on what kind of assets he has, how much salary he is drawing, and based on that, the government can come up with an engine within the database to calculate the tax that he or she is supposed to pay the government. In this case, it says $9,000 is the calculated tax by the government. And we will obviously have the information on how much tax he has paid originally. So say, for example, if the person has only paid $8,000 as tax, then it means that the person has paid less tax than what was anticipated by the government. So such a person can then be red flagged, and the information on that particular individual can be sent to the investigation agency, or that particular individual can be notified on finding out the reason for paying less tax. That is one scenario. Now, let's say, for example, the person has actually paid $9,000 tax, which is the correct tax. And is there still a way to find out whether that person is trying to do something fraudulent in nature? Which is what we can explore using the machine learning based detection methods. So say, for example, the scenario remains the same. We have the same person here making a good amount of money. He has invested in a car, he has invested in a good property, he has bank accounts with a good balance, and he is also paying the tax on time. But what if he has his spouse, his children, and they are registered with properties. And let's say, for example, if the spouse has a property registered under her name, but she may not be really paying the tax, she may not be employed, or she may not be having the income, and the person will try to do something fraudulent in nature by trying to offload the money using someone else. So he could potentially use his own close people in committing something which is fraudulent in nature. And the machine learning based detection enables you to write rules in which it can detect information that is related to a person and then can be visualized in terms of a graph, which will then enable the risk analytics team or the investigative agency to look into that particular pattern and make sure they can avoid that in the future as well. It's a follow-up on the same slide. So on the left, you have the individual evaluation. So based on how much money a particular person is generating, and based on how much he has invested in various assets, the government can calculate what category that person will come into, how much tax he's supposed to pay, whether he has paid the right amount of tax. They can all be evaluated based on the static information that we have. And on the right hand side, we have the competency scoring with indicators, which can leverage the machine learning models in the background and can identify how the various relations between people influences individuals to commit something which is fraudulent in nature, and how it can be visualized and stopped for the future as well. So it doesn't just help you in identifying the people who are trying to commit these fraudulent transactions. It also makes an organization or a government agency to plan well for the future and make sure to avoid these scenarios in the next tax cycle. Well, let's quickly get into the demo part of it. So we're going to introduce you to the Oracle Graph Studio. And Oracle Graph Studio is a very graphical, intuitive interface which will enable an organization to deep dive into the data that has been loaded into the in-memory engine. So it is not just the raw data that is loaded to the in-memory engine, it is the graph data which is derived from the autonomous data base related information and then get loaded into the in-memory and then get visualized using the visualization modules available within Graph Studio. So this is just a brief overview of Graph Studio. We'll be taking a look at each of these paragraphs that we have here. So to start with, the base information is that Oracle Graph allows you to have a notebook functionality, and the notebook functionality allows you to write paragraphs to organize the information. And there are three ways in which you can write the paragraphs. It could be a markdown, which is popularly called as the percentage MD. So we have now a different paragraph type here, which is percentage PGQL PGX. And similarly, we can have a percentage MD, which stands for the markup. And it's nothing but it allows you to write your text and then use it as a description. So if you want to publish the insights into the higher authority, and if you want to present this in a meaningful way, you can have a markup paragraph which clearly tells with its own rich set of formatting on why we have come up with such a graph and what is the importance of such a graph. In this case, I've just given a brief introduction for the heading for the tax fraud, and I have the information like what forms my nodes, what forms my edges, why I am using this notebook for, and what type of elements from Oracle Graph I have used in this particular graph. So any information that is descriptive in nature, you can include it in a paragraph with the percentage MD. And the next type of paragraph available is for the property graph query language, which helps you write a query for the pattern in which you want to visualize the graph with. So to start with, we'll introduce you to the very basics of the property graph query language. Just like how we have a select star from table in a normal Oracle SQL, we have a select star for the PGQL as well. So this says select everything from my graph by the name TF, wherein I want to look into all the information where it matches the pattern, which is this. So this basically means the I have a pattern, or I have to pick a pattern which starts from a source and it goes to a destination, and the transaction that happened in between. This could be a relation, it could be named R, the S could be named A, or D could be named B, so that it will be like A to B using an R. So basically, we want to find out all the relations that is existing in this particular graph. And once we execute this paragraph with this query, it then generates the below graph for you. So let's take a quick look at what it has generated. So to start from the extreme left, we can see that there is a person by the name Jahansep, and we can see an edge, and the edge is called by the name has underscore asset, which basically stands for this person has invested in a property which is called as Bavaria Tower. And in this itself, we can see that um, the calculated tax for that particular um, building in which he has invested is around 1 million, but then the tax declared by the person is only 500,000. So the person has tried evading tax by paying a very less amount of money, and that can be captured well using a visual representation. And then we can look into more detail. So it says the person is working in a air travel industry, and he is making a huge income for which he has paid a huge amount of tax as well. And we can see the declared amount as well. So it we can categorize the information of how much he has paid. He has paid around 200,000. The other additional information, like he has a child, then he has a spouse. So the spouse is bi-directional in nature. So Jahan Saib's spouse is Sumaira, and Sumaira's spouse is Jahan Saib. They have a child here, and they both have a child together. So here also they both have a child together. And then we can see that the lady is also making an income. She's a teacher for a government high school, and she has declared so much of amount. So it lets you unearth various types of relations along with the financial information that you're trying to commit as in relation being a citizen. And similar to that particular family, we have the graph available for every other citizen, which basically gives you insights into how they can be connected, what are the type of activities they are doing to make the tax submission fraudulent in nature. It helps the organizations to look into the high levels of detail as well. So moving on, we'll slowly start getting into the details of what extra do we have in the property graph query language. So say for example, in the earlier paragraph, we are just looking at everything that is available as part of the graph. Now, a graph will be like humongous in nature. It may involve information of all the citizens, and it could become a bit painful to look into the entire set of individual information. Um, so we usually start with some of the patterns, and if you want to identify people who stand out from the regular crowd. So say for example, if I want to find out people who has the maximum number of declarations, So we use functions like in degree or out degree. They are all like built-in functions available as part of Oracle Graph. So in degree is for the number of relations that are incoming to a specific individual, and out degree is the relation associated for that particular individual that originates from that particular individual. So in degree is more like incoming to an individual, and out degree is like outgoing from an individual. And we try to make a sum as the number of expected declaration. We want to get the name of that particular individual wherein he has invested in a lot of property, or he is also receiving a lot of money, and then try to identify that particular graph. So if you recollect in the presentation slide, we are trying to use the individual evaluation wherein we try to calculate the tax of an individual based on the assets he has invested in, and then we try to compare it with how much tax he has already paid. So we can use the built-in functions to identify the maximum number of declarations a individual or a citizen has, and based on a condition wherein the calculated tax is more than the declared tax, which means we want to identify individuals who has paid less tax, and we'll just take the top 10 of that particular list. So we can write such a condition and can get the list of people who could be influential in nature, and can give you the list in a very easy and fastest way by just writing a query by leveraging the built-in functions. And now we know that Jahan Seb Khan and Yusuf Haq have the maximum number of declarations made. And what if we want to explore more in detail into these two individual, and let's take the example of Yusuf Haq. So if I then want to understand into the pattern in which he has invested, how many people he has had relations with while investing in properties, I can um, do a pgvkl query, and I can mention to filter it by the name Yusuf Haq, and identifying a pattern in which yes, declared it with a for hop on that particular graph. So now we look into the graph that is generated based on that query, and we can see that it has given us back with all the needed information, how much income he is generating, what all assets he has invested in. So we can see that he has invested in multiple properties, and we also have the information on their spouse. The spouse has invested in an asset as well, which is a car. And we can also see that there is a common connection between one of the assets. So if you look at Bahariya Tower, and if we right click, it gives an easy indication that as part of this tower, the calculated tax is much higher. And we can see that it's like a joint property, or it could be like a pattern wherein the people were trying to evade the tax by having the same ownership, or people who are trying to share information between themselves. So this way, Oracle Graph Analytics helps you to explore the patterns in which they can unearth these insights, which is very difficult to, let's say, identify using a traditional analytics, because they are more focusing on just the numerical data and not just the patterns in which these numerical events happen. So that was just an example on how we can use the built-in functions to identify the influencers, and then try to identify the pattern in which they were executing or performing some of these transactions, which could be fraudulent in nature. And similarly, we can also identify persons in terms of the number of connections. So in degree and out degree, which are incoming to a person and outgoing from a person, they can also be used in relation to the number of connections I'm having in my graph. So it can help you identify how close you are to a individual in trying to influence that particular individual to do something fraudulent in nature. And the number of connections becomes very handy in those investigative areas. So we can see that it has given a different output against when we tried using the in degree and out degree for getting the number of expected declarations. So we can see that Ali Zarar Khan and Jamshed Patel has the maximum number of connections. So this is one way of trying to identify who has the maximum number of connections. The other way to identify an individual with the maximum number of connections is to execute built-in algorithms. So let's take a quick look at how algorithms can help you. As we can see, we have the third paragraph type here, which is percentage Java PGX, which enables organizations to execute built-in algorithms. There are around 61 algorithms available for the organizations to leverage very powerful graph analytics using Oracle Graph Studio. So once we execute the algorithm, we can um, um, uh, we can use that particular executed algorithm variable to write a PGQL query and then frame the communities. So let's say, for example, we take a look at this particular graph generated. So within the Graph Studio, I can click on my expand here, which expands that particular graph in full screen. Let's study this graph in detail. So we have like many nodes available, and we can also see that some of these nodes are highlighted in big circles. And this is basically to show how we can leverage the built-in algorithms to find the insights. So say, for example, we see that Ali Zarar has been highlighted in a big circle. Now, this could be like the person will be having a very high degree. So it highlights the importance of having the maximum number of connections. So this particular person um, can be highly influential in nature, and we can see that due to that particular person, the other set of individuals could be connected to them as well. So if if this person is trying to do something fraudulent in nature, it could be possible that in future he could probably influence a different individual who is connected using a common connection. So there are algorithms like centrality algorithms, which has concepts like finding the maximum degree, or let's say betweenness, whether a particular node can control the other group of nodes. So whether a person can control the other persons in the same group can be highlighted using the betweenness. So it basically says it could be a person, it could be an asset. So say, for example, let's try to go here. See, here we have one person by the name Jahan Seb, and then another person by the Yusuf Haq, and they are connected using the Bahariya tower. So this tower could act as an influencer, as an asset, which could have a better betweenness because they connect the other individuals as well. So that could attract an individual to commit a crime which is fraudulent in nature, and the interesting outputs can then be visualized and sent to the investigative agencies as well. So just like how we have degree and betweenness, we can also try to identify closeness. So closeness, it highlights those nodes that can reach the other nodes in a faster way. So say, for example, like we highlighted here, this is potentially a node that can connect or try to bring people with similar mindsets together. and similar to how we saw in Bahariya Tower. So this could also be an example of the closeness, wherein it highlights about those nodes that can reach the other people easily and the fastest or shortest way. So maybe to give you more example, Sain Shah. So Sain Shah could be an individual that could be reached easily through the connection between Babar and Ali Zarar, and through which we can see that the other people have invested in a lot of properties, and if they have something fraudulent in their mind, they can all be close using their connections, and that could potentially influence them to do something fraudulent in nature. But graph analytics can explore those insights and visualize it right in front of the investigative agency to prevent something for the future, or to try or find out who has committed something fraudulent in nature. And these are the centrality metrics. We also have the page rank, which is again one of the most common algorithms that are used to find out the importance of a particular node. So if we collapse this particular screen and then go down, we have the page rank. So just like how we executed an algorithm for the betweenness and then visualized um, the information from that particular graph based on betweenness, we can also use Java PGX as an engine to run page rank against a particular graph and then try to visualize it using the property graph query language, which can easily give you a visual representation of who stands out from the rest. And from this, we can easily see that as individuals, Yusuf Haq and Ali Zarar stands out, how they are connected to each other. We also have PageRank associated with the assets as well, and we can easily find out like which asset stands out, which asset tries to influence people to invest in them. This could be an indication to the government that most people are trying to invest in a very specific type of a property or in a specific type of a geography. It could give multiple insights into an investigative agency which they may not have really thought about using a traditional analytics. So these algorithms can also help you identify communities using the community detection algorithm. So just like how we executed the page rank and the betweenness, we also have algorithms for community detection, which can group the nodes into communities or clusters based on a very specific criteria. And based on those criteria, that can then be visualized on the screen using the Graph Studio. They can be exported or can then be presented to the higher investigative agency for more insights. That was a brief demo of how we can leverage the Graph Studio in identifying the patterns from an existing dataset. So now let's just go back to the presentation. Like we highlighted, graph analytics has a set of built-in algorithms, more than 60 built-in algorithms out of the box that helps you for detecting components and communities. So community detection algorithm, and within community detection, you can write or execute queries to find insights based on the strongly connected components, weakly connected components, and the rest that are highlighted. You can find how close nodes are connected using the algorithms for evaluating structures, for ranking and walking multiple algorithms available for different types of page rank, the centrality metrics, or the for finding out the betweenness and closeness, the eigenvectors, or the random walk with restart. They're all very helpful in identifying who is influencing in a community. So the more important is more like when we try to find out who is influential in a group of people, we also have to visualize it a different way, wherein what happens if we take out that particular individual or a set of individuals from a particular group, and how it will impact that particular group in preventing transactions that are fraudulent in nature. So that's the beauty of running algorithms like ranking and walking to um, um, to factor out people who stand out and make sure you drill into details on what will happen if those people does not exist in that particular group, or if you take those individuals from the equation from that particular group, will it stop fraudulent transactions from happening in the future? And we also have algorithms like pathfinding for the shortest path or the fattest path, for computing the distance index, the hop distance. So if the data set is like of huge volume, let's say a banking transaction, so banks will usually have a huge volume data set because there are financial transactions that are happening every second, and the data set may grow very big in a matter of few months. So you really need an algorithm to dive into this huge volume data set and then be back with all the parts they have found based on a pattern or a condition. So you have built-in algorithms for that. We also have machine learning algorithms like the deep walk, supervised graphways, or PG2 BC. And we also have the link prediction related algorithms as well. So graph analytics helps you leverage these built-in algorithms executed out of the box using Graph Studio, and then be able to visualize these results as well. How is Oracle Graph different? Um, the very important feature is the scalability and performance, like we highlighted. You get the data from an autonomous database. um, you have the in-memory component available that can scale based on the data that you have. So it is autonomous in nature. So the in-memory engine can be scaled based on the uh, volume of the data and based on the performance that we are expecting. Easy and accurate detection of cycles using the property graph query language, which can then visualize the insights on the Graph Studio. And obviously, it has the built-in graph algorithms and the graph visualizations. Um, and obviously, it can then be consumed by different layers of professionals, uh, ranging from data scientists to data professional to developers, the normal business analysts, the business executives, or if you want to use it for complaints purpose, to make sure you want to set your regulations for the future correct and accurate, you can use it for that as well. So Oracle Graph is like a complete package which starts from organizing your raw data into a well-structured data source, and being able to generate the graph models on top of it, being able to load it into the in-memory components, and then being able to query or execute algorithms to visualize it the right way for a government or a public service organization to make sense of it and then act on it for a better tomorrow. Um, like we always say, our mission is to help people see data in new ways, discover insights, and unlock endless possibilities. I hope this session was helpful. Thank you.
CloudDB, shaping your new normal.